Okay. What is PBR? Any idea? Anyone, any idea what is PBR, policy-based routing?
Policy-based routing.
What happens using PBR? Like what we can achieve?
Sending traffic in particular direction. Uh,
Okay. Look, yeah, exactly correct. Let's say if someone asks in the interview, like which one is a source-based routing protocol, which one is a destination-based routing protocol, right? So at that time, if I'll choose like, let's say AIGRP, RIP protocol, OSPF, right, BGP. So what these protocols does basically, they basically receive the packets from each other, right? They receive the information, uh, they receive the prefixes basically, and where they install in the routing table, correct? It means whatever we have in the routing table that is not belongs to me, that is basically the other routes, right? It means those are the destination routes, and whenever any of the packet comes to the router and the router is checking routing table, it means that is looking for the destination route, right? Correct. So whenever any of the user, any of the routers verify the routing table to do the forwarding, that is basically a destination based routing protocol. So whenever you talk about like RIP protocol, static routing, or let me take like AIGRP, OSPF, or BGP, right? So all these are basically destination-based routing protocol. But when we say I'm going to do a source-based routing, right? A source-based routing, it means by checking source, I want to route the packet. Okay. It means let's say I'm getting a packet. I'll draw a diagram. We have, let's say, R1 that is connected to R2, that is connected to R3. Okay. We have a user here. We have another user here. This user is having IP address 10.0.0.1. This user having IP address 20.0.0.1. Right. In this condition, whenever this user will send the packet out here, the source address will be this one and the destination would be this one, right? So whenever R1 will verify 20.0.0.0 in the routing table, right? That is basically looking for the destination route or destination things that is checking, right? Now what I want here, R1 should not verify the destination. It just only check the source address. If the source address is this one, then do one thing, route the packet out to R2. It means what we are doing here, we are creating policies to do the forwarding. Okay. We are not using routing protocols to do the forwarding. We are using the policy to do the forwarding by checking the source IP address. Okay. Is that clear?
Yes, sir.
Okay.
yes.
Now it
So
has,
we will not use any routing protocol here.
yeah. Okay, guys, what happens actually? Let's say, just tell me one thing. What is the difference between static routing and dynamic protocol, dynamic routing protocol?
Statics are like statically configure the destination to
We
reach
manually
particular
provides the
destination.
route.
Okay, and dynamic protocol?
It will calculate on its own, like
Exactly.
destination. Yeah,
Perfect. This
best
is
routes.
very perfect. Excellent. Right. Now the question here is, what is the loophole we have in the static routing? Why we should not use static routing?
For bigger
Sure.
network, it's very complex to configure.
Exactly.
Limited hop.
But still we configure somewhere, like let's say towards ISP network, right? Let's say
Yes,
I do have one ISP or two ISP. So definitely I'll be using static routing. I'll not be using any routing protocol. Even the ISP will not allow to run the routing protocol, correct?
yes, sir.
Correct. Okay. Same here. We can use PBR everywhere, but that will make the routing complex. Okay. It means I can't go to every single router and configure the PBR. No, I can't do that thing. Okay. That will make complex network, right? If I want, I can do, but I will never configure. Reason being, I'll be having issues at that time because in case of failure of any link, right, I need to do the modification just like a static routing. Okay. So
Yes,
for
yes, sir.
routing, where we use policy-based routing, just in the case of where we have such a requirement. Okay. So I will draw a diagram and where we will be having some requirement. Okay. And then we'll see what we can do. Okay. Let's say we have these users, right? These LAN users we have. Okay. So in these LAN users, basically, let's say what I want here, the ISP1 should be the primary, ISP2 should be the secondary. Or, sorry, my mistake. I do have two ISPs. Okay, what I want here, R1 should be the primary gateway, R2 should be the secondary gateway. How we can achieve that part? R1 is a primary gateway, R2 is a secondary gateway. How we can achieve the part?
Can you repeat the question if you don't
Yeah, the
mind?
question here is, we have these users, these LAN users. Okay, they will be now. What I want for these LAN users, whenever they want to communicate to the internet, then R1 should be the primary router, R2 should be the secondary router. If R1 goes down, then R2 should be active.
So HSRP, I can use HSRP in between them.
In the switching, we have a protocol that is basically HSRP, right? HSRP, VRRP. So what will happen at that time? Let's say I'm using HSRP. These are Cisco router and we are using HSRP. So what will happen here basically? This interface or whatever virtual IP we are using here, that will act as a primary over here and secondary over here, right? Now, let's say this is a primary. What will happen here? All these users, let's say all these belongs to 10.0.0.0/8. All these users will go via this router. Now, if you see here, if in case this ISP is always up for next 10 years, right? I don't have any issues over this link, right? So these 10 years, I'll not be using this link, right?
Yes, sir.
What I want here, I want to utilize that link also. Let's say half of the users, 10.0.0.0 on slash, let's say what I want here. 16. Okay. How we can divide it into only two parts? Any idea? How we can divide 10.0.0/8 into two parts only? What you can do? I want to divide this into two parts. Any idea, guys? Very specific, like I want to divide this into very specific two parts. That's a kind of subnetting.
Exactly two parts.
Exactly two parts. Yeah. Because what I want, 50% users should go via R1, 50% users should go via R2. So first of all, we have to perform the subnetting, right? What will be the subnetting answer here?
Slash.
What slash you'll be using?
/12.
Why? Okay, should not waste the time. It will be 10.0.0.0/9, 10.128.0.0/9. Okay. Look here, you told me like /12, right? 10.0.0.0/12. What will happen here? We have 4 bits. It means fourth number 16 bit. It will divide like 10.0.0.0, 10.16.0.0.0, right? 10.32.0.0 and so on in this way. Okay.
Yes, sir.
I wanted to divide in only two parts. Okay. So /9 is the best way. Okay.
Okay.
Now, okay. As of now, what will happen here? First of all, the traffic will not go to R2. All these users will have a gateway and the gateway is enabled over here, right? I don't want to use other gateway. Okay. So what will happen here? First of all these users will come to this router. That is fine. Now what I will do here, I will configure a policy over this interface. I will say whenever you will get a route from any of the user belongs to this subnet, do one thing, set a next hop to R2. Okay, it means whenever any user comes here, if that belongs to 10.0.0.0/9, that will say, okay, I don't have that subnet over here. I'll just check my routing table and that is pointing towards ISP. I will send the traffic out here. But if the policy matches here, right, using this address, any of the user from the subnet, right, that will say, okay, now the next stop is R2. I have to route the packet out towards R2, and then R2 will check routing table to do the communication. So this is how we can route the packet. And if you see, this was a specific requirement, right, on this router to perform this kind of routing. So in such requirement, we configure policy-based routing. Okay. It is clear?
Yes, sir. So in such type of scenario only it is feasible to use.
Yes, exactly. Because
But
we can't use like everywhere steady, everywhere this
yes,
policy-based routing.
yeah. So but if R2 goes down, then what will happen, sir?
Okay, if R2 goes down, then all the traffic will be dropped. But what we can do basically to make this happen, we can use a track feature also. Okay. Inside PBR, you can use a track feature, like whatever next stop you will define over there. Let's say you are defining a next stop of R2. You can put a track over there and you can track R2 even at that time. Okay. Clear? So you can track R2 IP address. If R2 is available, then this IP is active. Otherwise, do your task. No worries. Okay. Because even I want over there, right? If R2 goes down, then the traffic should go to ISP1 directly now, right? It shouldn't go to R2. So what we can do, we can use a track value, just like in the static routing we do tracking, right? Exactly in the same way here to the next row, we can use a track. Okay.
Basically, you want to do IPSLA, right?
Yeah. Yeah. Yes. Same thing. Yeah.
Okay.
Just like we did for the static routing, exactly in the same way we can do it here. Okay. Now, okay. Any questions? Any doubt in the concept? Anyone? All good?
All good.
Yes, sir.
Now we have two types of basically this PBR. One is your interface based PBR and one is your local PBR. What is interface based PBR? Whenever router will get the traffic on interface and want to do policy forwarding. It means a router is getting a packet on the interface, on any of the physical interface, okay, and it is taking a decision. That is called your interface based PBR. Now, what is local PBR? Router itself want to route a packet to a specific router. It means, let's say we have R1 that is connected to R2, that is connected to R3, R4, and so on, right? We have, let's say 1.1.1.1 loopback address here. One is 11.1.1.1.1. And the destination is 4444. Even I'm using rounding protocols. Now, what I'm asking here to the R2, whenever you get a packet with the source address 1.1.1.1.1, do one thing, send the packet out towards R3. Now that will take care. Okay. So it means I'm getting a traffic over this interface and then I'm taking decision. That is called as interface based PBR. But whenever R2 itself, let's say it has two loopback addresses, 2.2.2.2 and 2.2.2.1, right? I'm asking R2, whenever you will try to do a ping, let's say on R2 itself, I'm doing a ping to address 4444, right? And using source address, let's say 2.2.2.1, right? By default, what will happen here? It will route the packet directly towards R4. what I want here, it should do the policy-based routing. Then whenever I will say to router itself, whenever you itself will do the routing using source address 2221, right? Do one thing, send your packet out towards R3. Do not check your routing table. It means the router itself is taking a decision that will act as a local PBR concept. Okay. So we have two things. One is the interface-based PBR and one is the local PBR. Okay. Interface-based PBR, I will be getting the traffic on the interface. Local, so router itself will originate the traffic. Okay. It is clear?
Yes, sir. Can you repeat, sir, local again, sir?
Yeah, local is like a router itself want to do some task. It means a router is not getting traffic on any interface, that itself is originating the traffic. Okay.
Okay.
When we can do a communication. Let's say R2 want to check the connectivity, right? It can use any of the loopback address, correct? So
Okay.
the router itself is doing a ping, right? R2 is not getting any traffic anywhere, correct? So that is basically local PBR, or we call it global PBR, might be. Okay.
Okay. So self-testing router is using this.
Yeah, exactly. When a
But
router
in
itself,
practical scenario, user cannot use the local PBR.
yeah, user will be using interface based PBR, and the router itself will be using local PBR.
Yes, sir. Okay.
Let's create this topology and we'll see how we can achieve this. Okay. So as of now, we are doing a communication and that is going very well. If I'll do a trace to 4444 using source loopback 0, that is going via R2 and then R4. If I'll take loopback 1 also, that is going via R2 and R4. Now what I want here, whenever I'll be using a loopback address 1.1.1.1.1, let's say I'm using address here, source, that is going via R2 and R4. Now what I want here, it should move towards R3. Let's go to R2 then, right? On R2, we can achieve this task. The very first thing, we will configure ACL. Access list 1, permit 1.1.1.1, 0.0.0.0. We know how to configure ACL, right? Now configure your route map. Route map. You can use any name you can use. Let's say int PBR, int PBR. Okay. Match IP address 1. It means match your ACL first of all. Then set IP next hop. What next hop you want? R3. That is 23003. And then you see here. Okay. Okay. In this OS, we don't have those feature to track the next hop. Okay. But in the big OS, you will get it. Okay. In the newer version of OS. Set IP next hop. Exit. Now go to the interface level on which you are getting the packet. So R2 is getting a packet on F0 by 0, right? IP policy route map name is int PBR, right? Enter. That's it. How we can verify? Show IP policy. You see on the interface number 5 F0 by 0, what we have? A policy based routing we have. Now let's do a trace using 1.1.1.1. Now you see the packet is traveling via R3, correct? It is clear. So this time the packet is traveling via R3, not directly to R2 and R4, right? So this we have done a policy based routing using interface. Okay. Interface based PBR basically. Clear? Any questions? Any doubt?
Sir, what is VRF? I have not seen this.
That's a global table basically. Virtual routing forwarding. So by its default, we have a single VRF, a VRF routing table, a global table. When we start advanced BGP MPLS, that time we will discuss these things. Okay.
Okay, sir.
So, can I ask one question?
Please.
So is there any other way other than policy-based routing? Can we route traffic to a particular router? Like, let's say the same based on the source IPs. Can we uh, pass the traffic to particular destination, a router?
No, no.
So what is
Uh,
VRF?
One is
VRF. Virtual routing protocol, right, sir?
yes,
Forwarding.
forwarding.
So this is the way they are doing the VRF first.
That's a global VRF. A router has a global VRF, okay? A global routing table. Money, like we don't have any such way to do this task now. Okay? So either we can use policy-based routing or we can use directly routing protocols only. Okay.
Yeah.
Do you have any questions, any protocol you're thinking?
Can you explain one more time, sir, about this routing?
Okay, Dilip, just one by one, right? Money,
Yes.
your doubt is clear.
It's clear, but I'm just thinking, like, is there any other option? Like in BGP, we use metrics to, like, let's say we have WebEx and Teams traffic. So we use particular prefixes and we say like, we want to use this ISP and we want to use this ISP.
But money, yeah, money. What happens at that time? BGP, whatever policy I will apply over there, the final thing will be like I will install the routes in my routing table, correct?
Okay.
And that
Yeah.
again becomes a destination-based routing, not a source-based routing, correct?
Yeah. Okay.
Whatever policy I will apply in the BGP, right? The final
Mm.
decision will be based on the routing table, right? Because the final decision is putting the best route in the routing table, correct?
Yes.
So PBR is the only way to do such tasks. Okay.
Okay. Got it.
Yeah.
Yeah.
Dilip, your question now.
So can you do one more time explanation, sir? That routers.
For which one? PBR?
Yes, sir.
Okay. So what we are doing here, let's say if I'll be using, let's say, a static routing, let's say I'm using, or dynamic routing protocols, right? So
Yes, sir.
what happens at that time, using those protocols, the routers take the decision on the behalf of destination. So all those are destination-based routing protocol, okay? But whenever I want to do a routing on the behalf of source, right? So which protocol we can use? That is basically policy-based routing. So using policy-based routing, what we can do, we can match the source address and we can take a decision on the behalf of source address. Okay. So what we do, first of all, we configure ACL to match the source address, and then we configure the next hop IP address where I want to route the packet using the source combination. Okay.
Yes, sir.
It is clear.
Yes, sir.
So using PBR, what we are doing actually, we are just routing the packet, or we are just routing the packet, forwarding the packet by checking source, not by checking destination. That's it. Okay. That is a difference we have. Otherwise, like forwarding we are doing actually, right, in both destination based routing protocols or source based routing, right? But what we are doing here in the source based, we are matching a source actually in the PBR, right? The source address we are matching. Now the destination doesn't matter. Whenever the user 1.1.1 will come to R2 to any let's say to any destination basically, right? The route will always forward, the router will always forward the packet out towards R3, not towards R4. Okay. Clear, Dilip? Dilip, this is clear.
Yes, sir.
Dilip, if you
Uh,
have any questions, you can ask. Any questions if you have.
Neeraj sir, I have just a curiosity question.
Yeah, please.
Can you go to the topology?
Yeah.
So let's say if I apply a deny rule under router 2 port F10,
Okay.
like just instead of policy based routing, I just want to create a ACL and I will apply deny. So whenever I see 1.1.1, I don't want to use that port. Definitely it will try to go from the other path, right?
No, no, no. What happens actually when we talk about this router, it
Mm,
has a sequential thing. First, I'll do this task, then I will do this, then I will do this task, and then I will do this task, right?
okay.
It means if that is successful, I will go to next. If that is successful, I will go to next. So what will happen here? While receiving the packet here, that will verify, oh, I'm getting a packet with source address 1.1.1.1. Perfect. And what is the next hop address? The next hop address is 23.0.0.3. So I will take a decision. Now R2 will start looking for, because whenever the router gets the packet, they remove the layer 2 header, right? Now R2 will be looking for the new headers, new layer 2 headers that R2 can use to reach 23.0.0.2, right? Correct?
Yes.
It will add those things in the packets basically. Source is
Mm,
this one, destination is let's say 4444. It will add source address MAC address this one, destination MAC address this one, and while putting the packet over this link, it says,
mm,
oh shit, what we have here, we have the ACL, and that is trying to
okay.
deny 1.1.1.1, and then it will
Yeah.
drop the packet. Okay.
Yeah. It won't even try to go to the other interface. Okay. Got it.
Yeah, it will drop the
Okay.
packet.
Yeah. Thank you.
It is doing a sequential thing, right?
Yeah.
That's why.
So, sir, let's say we have more routers over here, 7, 8, 9, 10, like this. So if we want to forward the packet from R1 to R2 and R3, so
Yeah.
that will go to R2 and R10, let's say. So
Yeah.
we configure on each every routers,
We have
this
to
kind of
yeah,
configuration.
we have to configure, otherwise we use routing protocols. Okay. Because
So,
policy based routing we never use everywhere, just like static routing we use with ISPs. So even PBR we use just like ISPs, like I want to route a half of the traffic via that way, half of the traffic via that way, or for a specific server I want to send the traffic via ISP1, ISP2, right? So for a specific task we use policy based routing, not for random task. Okay. Or not for all the routers. Okay. Like we did earlier in this one, if you see, I was having this diagram. So in this diagram, what was the requirement? Half of the user should go via R2 and ISP2, right? So I was taking a decision over here at that time, correct?
Yes.
I'm not using this as a routing protocol everywhere. I'm just using this protocol just to do the forwarding on R1 for the rest of the traffics, right? Rest of the user. Clear?
Yes, sir.
Okay. Now, let us talk about the local PBR. Local PBR, it means whenever R2 originate the traffic from itself. So it is like look here, I'm doing a ping. Okay, let me do trace directly. That is going directly towards R4, right? What I want here, whenever this router itself will do communication using address 2.2.2.1, then do one thing, send the traffic out towards R3, not directly towards R4. It means do not check your routing table. Okay. So again, same thing, configure access list, permit your information. Okay. Configure a route map. Name is PBR. Match IP address to match your ACL. Set IP next hop is 23.0.0.3. Go out. Now in the global mode, earlier I was going inside the interface level, right? Now we have to work on this mode basically directly in the global mode, right? IP local policy route map. Route map name is PBR. PBR. Enter. How we can verify? Show IP policy. If you see, I do have an interface-based PBR and I do have a local PBR, right? Correct. Now let's route the packet. Trace 4444 using source address 2.2.2.2. If I will take 2.2.2.2, that will do normal routing. You see, that is doing a normal routing by checking destination. If I'll make it 1, that is going via actually R3, right? It is clear?
Yes, sir.
Any questions, any doubt? All good?
Yes.
Great.
Sir, I have one doubt.
Yeah.
Router ID is 2.2.2. Only you told it. So here you're giving one.
Okay, I have configured 2 addresses, right? Look here. I was using 2 loopback addresses.
Why you are using two back addresses, sir? That will be my question.
No, just to show you, right?
Oh,
Just to show you. The thing I will match 2.2.2.1. If I'll use that source address, that will go via just like our PBR. If I will
okay.
not match any address, that will go directly to the destination.
Okay.
Just to show you.